So welcome to the second section of our Vulkan API trainings video. In this section we are really going to take a first look at what we can code in Vulkan, and we will take a look at what I call it the Vulkan elements. So the different parts of Vulkan which we need to program to get the proper behavior and appearance that we want to have. So in this section we are going to take a look at a few things. First of all, we are going to take a look at the so-called Vulkan instance. This is the starting point of everything. This is where we keep all the major information about the Vulkan application that we're currently writing, and we need to configure it properly to be able to use it. We will take a look at the so-called surfaces. Surfaces are a general concept in Vulkan, which allow us to present the information that our Vulkan application has created on the screen. But surfaces split up a bit. There are operating system related surface actions, and as well operating system independent surface actions. We will take a look at those in detail when we come to the proper section. We were going to take a look at the devices. In Vulkan, a device is actually a physical processing unit inside your operating system, inside your PC or inside your MacBook, whatever you're using. So we will need to take a look at the devices, understand what they are. We need to query the devices inside your computer to see which are for us comfortable to use, and we will need to configure the device for proper use as well. Then we are going to take a look at the swap chains. The swap chain actually is some kind of circulating buffer which allows us to present different render results on the screen at the moment that we want to show them on the screen. But they are a bit tricky, so we will take a look at them in detail in this section. And then we will take a look at the images. An image in Vulkan is whenever you present something on the screen, or even if you're just creating images off screen which are never presented on the screen, you need to store this information in something that is called an image. And these images go together with the swap chains as well. So in the sections where we're talking about the swap chains, we need to make use of the images anyway. After that, we are going to take a look at the queues. The queues allow us to record and play back certain commands for the rendering process in a special way. So we will take a look at the queues, how to record them, how to record the so-called command buffers, and how we can process them in the render loop to get the proper render result in the end. And as well, we are going to take a look at the so-called frame buffers. A frame buffer allows us to store the render information in a certain way, not only the color representation of a render result, but also the depth information or the so-called stencil information. So the frame buffer actually includes all the information for one rendering pass, and we will get to know them and to see how to set them up properly. A few words on the coding in Vulkan in general. In other APIs like OpenGL, nowadays you only write a few lines of code and you're fine. In Vulkan, nowadays you need to write a lot of code to get a first very simple result. The time that we can invest in this video training is a bit limited, so we need to simplify some points. My goal with this trainings course is to get you familiar with all the basic ideas and concepts of Vulkan. So at a certain point I will shrink the code a bit just to get you into it, and you should get a basic understanding. But just keep in mind, we need to write a lot of code, but a lot of the basic concepts in Vulkan will repeat over and over again, and I'm quite sure at a certain point you will realize, even though we are writing a lot of code, we are repeating stuff. It's always the same idea, it's always the same structure, and I hope you will find your way into this. In this section we are going to take a look at the Vulkan instance. This is really the starting point. This is where it all begins. The instance is somehow our major handle to the Vulkan application and to all the coding. So we will use it in the following sections as well, and somehow always reference to it to be our basis of the Vulkan application. So in this section we are going to take a look at two things. First of all, we're going to take a look at the vkey application info and the vkey instance create info. These are both structs that we need to define and set up properly to be able to even create the application. And then we are going to create the VK instance by calling a proper function given to us by Vulkan. To create our Vulkan instance, we first of all define a global handle to it. We just make this variable global because we want to access it anywhere in our code. If you would code this a bit more clean, you could bring it into a namespace and you could keep the handle there. To create an instance, we first of all need to create the VK application info. And you see it's a struct. So all this information that we need to create in our Vulkan application are always defined in structs, and those structs are then used to create something. So this is a basic concept that you will see over and over again while we are creating our Vulkan application. So let's take a look at the VK application info closely. So first of all, we've got the S type, the type of this information struct. And we just give the proper information about it, what it is. We need to give this S type information because at some point while processing the Vulkan application, these structs may be passed by void. And if you have a void, you don't know what this structure is all about. So first of all, we always need to give the S type so we know this structure is a certain type of information. The pNext may only be relevant later if we are working with extensions, so we skip this one now and just set it to null to be on the safe side. Of course, we can give it an application name. Our application now gets just the name Vulkan program. We are fine with this. We can give our application a version, and we could even give it major and minor version numbers, but for now we are fine just giving it the version number 1. We could give our application an engine name as well. We could reuse, of course, somehow our code later, so it would make sense to give it some engine names, but for now we are fine just giving it a null pointer here. We've got an engine version that we could as well alongside to our engine name. So let's take a look at the elements of this VK application information struct. First of all, we've got the S type. The S type will be there in any structure that we create in Vulkan. The S type just tells the struct what kind it is, and we need this because later in the application process some of these structures may be passed by void, and so the application needs to know what type we have chosen for the structure. Then we've got the pNext. The pNext should not be relevant for us right now. It would only be necessary if we are going to start with more extensions, so we just keep it by null. Of course, we can give our application a name, and this is what we're doing here, so we are just passing a string telling the application name is Vulkan program. If we want to, we can give our application a version number. Of course, we could add major and minor versions here, but for now we are fine just passing a 1. Then we could give it a so-called engine name if we want to. This would again just be a string. In this case, we don't need this. And I would set the engine version to 1 or 0 because we don't make use of it right now. In the end, very important, we've got the API version. Right now, we have two choices here. We could place a 0 there or just tell it VK API version 1.0 because this is all versions which are available right now. If you're watching this video at a later point in time, it may be really another version available, but for now we are fine with this. So now we've created this application info. But the application info on its own is worth nothing. We need to use it with a different struct to be able to really create the application instance. To create the Vulkan application instance, it takes a bit more, but again, it's just a struct. And you already see that some elements of the struct look familiar. Again, the VK instance in createInfo has an S type, and just like we used it before, this S type just tells us what type is this struct that we are going to use here. We again got the pNext, we will just keep it by null as well. We've got the flags, which are meant to be used later in Vulkan, which are not used right now, so we can set them to 0 as well. And now we've got the application info. Indeed, it's a pointer to an application info. And this application info is the struct that we've just created previously, and we are adding this one here giving a pointer to the struct of it. To work with Windows later, we need to have some extensions included, so we tell them that the enabled extension count is 2, and these extensions are only used for creating a surface and using this surface inside a Windows 32 window. When we come to the surface section, we will talk about this one a bit more in detail. And we've got the so-called layers. Layers are there for debugging and for other purposes. In our case, we just put in a default layer, and we just tell the Vulkan application that we have a layer count of 1, and we just tell him he can find our layers here given as constant char arrays. So we just pass the pointer to them. So now we've got a populated struct of the VK instance create info. And this is all we need to really create the instance. Just a few more words on notation here. You see that the Vulkan structs always start with a capital V and then go on with a smaller k. So you can always identify a struct by this type of writing. When it comes to Vulkan function calls, we start with a small v and a small k. So you can easily identify always if it is a Vulkan function call or Vulkan struct. Okay, but let's use our first Vulkan function. In this case, it's vk create instance, and we need to pass a few informations to this one. First of all, we pass the vk instance info that we have just created. And remember, this vk instance info as well includes our application info created previously. For the second parameter, we don't care about it right now, so we just pass a null there. And as a third parameter, we are passing the global instance variable that we have created, which will now keep the instance of our Vulkan application. Of course, only if this call to vk create instance is successful. So vk create instance does not return an instance, but it returns a result which tells us if this creation was successful, yes or no. So what we need to do, of course, we can write ourselves some debug functions or macros to use to check if the value in the result tells us that the creation was successful, and we can of course stop our program if it was not successful at all. So with these few lines of code, we have created an application info and we have created an instance info. And if we use both of them with the vk create instance, we really get our first Vulkan instance, and this is the starting point for everything. Later, we will make use of this instance whenever we are using other Vulkan functions, because we always need to refer to this instance as our base of the application.